How Do You Lift a Lion by Robert E. Wells. Did you ever try to lift a lion? You'd have to be awfully strong. It's because of the force of gravity. Gravity pulls objects downward. When that object is as massive as a lion, it pulls pretty hard. With a lever, you can lift a heavy weight with much less effort. Here is an example of the lever that's being mentioned in our story. So I know that it's spread out on 2 pages in our book, so it makes it kind of tricky to see the full machine when it is spread out like that. So our lever is this red machine right here that my lion is stepping on. This is not the only way that a lever can look. There are actually many different variations of levers. What I'm going to draw on the board is an example of a common type of lever that I'm confident that we have all seen before and most of us have probably used. It's something that you might find on a playground. So as I'm drawing, think of where on a playground you have seen this example of a lever. If you said that this reminds you of a seesaw, you'd be correct. A seesaw is an example of a type of lever. The main part of the lever is a bar or rod, which balances or pivots on a fulcrum. If the force side is longer than the load side, you will have leverage. Leverage adds force to your own strength, making it easier to lift heavy objects. With a force side this long, you could lift a lion. We said that a lever is a machine that is composed of 2 parts. The first part is a bar. That's that very long, thin piece right here that turns around a fixed point called a fulcrum. My fulcrum in this example is right here. It's all the way at one end of my lever. So what I'm going to do is draw that example of the lever in our story as kind of what it would look like if it were a seesaw. So it would look like this. And here would be my lion. I have my bar that's turning over my fulcrum. In my seesaw, I also have my bar that turns around a point called a fulcrum. My fulcrum in the example with my lion is closer to where my lion is than my seesaw example, where my fulcrum is in the middle of my bar. Now, do you suppose you could lift 10 lions? Our story just shared that the closer our fulcrum is to our load, the thing that we are lifting, the easier it is to lift that heavy object. So my fulcrum in this example is closer to where my lion is because it makes it easier to pull down on the other side of that lever in order to lift my lion up. This creates leverage. Leverage makes it easier to lift heavy objects. If I had my fulcrum in the middle of my lever, and I had my lion in the same place, it would be more difficult for me to lift the lion with the fulcrum in the middle than if the fulcrum were over my load. Similarly, if I had my line at one end and my fulcrum all the way over here away from my load, my lion, it would be very difficult to lift this load because I would have less leverage. The longer the force side is compared to the load side, the more leverage you will have. So, if you had a lever with a handle this long, maybe you could lift them a little. Take a look at how long the handle that my friends are pulling down on is compared to the area on the other side of the fulcrum where my load is. My force side, the side that my friends are pulling on, is many, many, many times longer, which allows them to have greater leverage and which makes it easier to lift this heavy load. Did you ever try to pull a panda on a pallet? It would be pretty hard. Gravity is pulling down on that panda. And there's also friction between the ground and the pallet. Friction, or resistance, happens when two surfaces rub together. The more weight pushing on the surfaces, the more friction there is. So now we have a different animal and a different set of problems. We have our panda that's on a pallet, which is a fancy term for kind of just like a big block of wood. And we're trying to move him over the floor. So we're trying to pull that pallet with the panda on top across the floor. And we said that that panda is super heavy, so gravity is pulling that panda to the ground, and the pallet and the floor are rubbing together, which is creating friction or a force that's going to go against the movement of that pallet when we are able to pull it. What could we add to our pallet to make it easier to pull this panda? What do you think? If you put wheels on your pallet, there would be less friction and you wouldn't have to pull quite so hard. Wagon wheels are mounted on axles. At the wheel's center is a bearing, which turns on the axle. A bearing's inside surface is smooth, so it makes very little friction. Oiling a bearing's inside surface makes it slippery, so it has even less friction. This is called lubrication. Here we have a picture of a scooter, and you'll notice this scooter has two wheels, one in the front and one in the back. If we look more closely at the individual wheels on this scooter, you'll notice that our wheels are attached to the body of the scooter at the axle. So the wheels themselves don't touch the scooter's body. The wheels are connected at the axle, which then connects to the rest of our machine. Wheels with bearings make much less friction than pallet bottoms. That's why you can pull the panda now, even though he's just as heavy. If you begin to go downhill, gravity takes over to pull your load. Gravity not only pulls objects straight down, it pulls them down slopes too. So, now that you don't have to pull, you could carry a much bigger load. Take a look. I have my board eraser on top of this iPad. My board eraser is resting here because gravity is pulling it towards the ground, and this is in the way of the ground. If I were to move my iPad and let it fall, it would hit the ground. Now, with it resting on my iPad, it doesn't go anywhere. However, if I start to tilt my iPad, my eraser begins to fall because gravity doesn't pull objects just straight down. It can pull them down slopes too. This is why if you're in a playground and you go down a slide, your body travels from the top of the slide down the bottom. Gravity is pulling your body down that slope. Now you could carry a pyramid of pandas. And the steeper the slope, the faster gravity will make you go. If the slope began to get very steep, you'd probably wish you had more friction to slow you down. Did you ever try to deliver a big basket of bananas to a baboon birthday party? It would be mighty heavy. My baboons are partying it up in this tree. My basket of bananas is at the bottom of the tree. There is a way to get all of these bananas up the tree at one time. It requires the use of a new machine that we haven't discussed yet. See if you can brainstorm what kind of machine you could use to have this basket of bananas delivered up to our baboon birthday party all together. With pulleys, it would be much easier to lift. A pulley has a wheel with a groove around it to hold a rope. When you lift with one pulley, your lifting strength stays the same, but the direction of force is changed. So just like with my lever, if I'm trying to lift my lion up using a lever on the side of the bar that I'm using, I would have to pull down in order for my lion to go up. If I'm trying to deliver a basket of bananas to a baboon birthday party, when I pull down on my rope, my basket of bananas travels up. With two pulleys, your lifting strength is doubled. You'll use twice as much rope, but you can also lift twice the load. When we have loads that are really, really heavy that we need to lift, oftentimes we'll see systems of pulleys. So think about a crane that lifts really, really heavy objects, perhaps in a construction site. So we're building a building and we use cranes to lift that heavy equipment. Oftentimes, if we look at that crane, we'll see multiple pulleys working together. That's because the more pulleys we have, the easier it is to lift heavy loads. So we might need more string to accommodate or to meet the needs of those different pulleys. However, it makes that job much, much easier the more pulleys we have. Yes, pulleys make it much easier to deliver a big basket of bananas to a baboon birthday party. But perhaps a smaller basket would have been better.